Hey everybody, this is Larry. This is day 7 of the January Leetcode Daily Challenge. First week ending. Let me know how it goes. Hit the like button, hit the subscribe button, join me in Discord. I usually attempt to solve and explain these problems live, so let me know what you think about the format. And if it is too slow for you, feel free to fast forward. I tend to go over my thought process, and that's what I like to do. Okay, and today's problem is longest substring without repeating characters. Given a string as, find the length of the, okay. So this is going to be a sliding window thing, which is in a way a sort of greedy and trying to figure out an invariant that is true. And the reason why this is that given any substring any substring without repeating character, you could greedily add one to the left or to the right if it does not make if it does not repeat any characters, right? So that's basically the idea, and then now we just have to kind of have two fingers, and go, okay, let's say now we want to add in this character to the right. What happens to the things on the left? Well, now you have to remove until it's good to add this character. So that's the idea, and many variation of this problem is on Leetcode and different competitions. So definitely practice this, and even upsolving it and doing in linear time. I didn't even look at the length, but because I know that's going to be linear time, it should be okay. And when I say about invariant, we'll go over the loop invariants as well. So let's kind of get started on the implementation. Cool. So how I like to write, and there are a few ways to write it. Just I like to set left is 0 to 0. Sometimes I use a while loop. Sometimes I use a for loop. It just depends on what makes sense and how the pointers get moved. In this case, we want to move the right pointer every time, and then just make sure that the left pointer holds the invariant where nothing between the bounds, inclusive, contains repeatable characters, right? So now let's say, let's have just inset, maybe. I don't know if that's a good name for it, but it's just to keep track of characters that are in the set. So then now it becomes if or while s of right is in inset. That means that, what does this mean, right? This means that we want to add this character, but it already exists in the bounds that we keep track of. So now we have to kind of move it. We have to make it so that it doesn't, and that's how we get the longest substring that ends at this current character of the right bound. So that's kind of the way that I would think about it, and that's let's see, inset dot remove s sub left increment by 1. So and in this case, there's also a few invariants to it, which is that even though normally otherwise you may see errors, right? Like for example, this removal. Well, we know that the precondition is that because left is going to be on the left side of the right, makes sense. This can only be true if we added it before, so this will never give us an error about not found. And in this case, left, we increment in until left is less than right. Maybe you can write something like that, but it's not necessary because of the invariant that once left is equal to right, then s sub right should never be an inset, right? So that's why the way that we write it. And then at the very end we add s sub right. That's fine, and we want to keep track of what I call the best, which is the longest. And in that case, we just set it to the max of the best, or if the current length, which is right minus left plus 1 because it's inclusive bounds, to be the current length, and this is the longest length of a substring that satisfies non-repeating characters that ends at the current character, right? at the right bound. And that's pretty much it, really. This is a very fundamental, very basic, relatively two-pointers algorithm, so definitely get familiar with this one because it only gets harder, to be frank, with different variations. And as long as you're able to kind of figure out the invariant and the loops, then these should be pretty, it gets harder, but you can build on what we have here, right? So yeah, and there are a couple of key things to this. One is knowing that this is a set, because then now this is an O of one operation and this is an O of one operation. Because you can imagine that if you just put on a naively, for example, a list, then it could get n squared because you're doing a search every time, right? And that's too slow. And this time, speaking of that, complexity is only going to be linear because for every item that's in S, we add it once, at most once, and we remove it at most once. So that means that we only add and remove once per element, which means that this is O of one number of element, or O of one time per element. So it's going to be O of n number of total elements, or time for total, right? And in terms of space, of course, we do keep track of a set, so it's going to be linear space and reverse time. Cool. That's all I have for this problem. As you can see, we got to accept it. Yeah, again, this is relatively basic. And I don't mean that to say that, you should feel not good for not getting it. But I just mean that, you don't feel like you're able to solve this very comfortably. Definitely practice it because it comes up all the time in various different ways. So, yeah, and the condition here is relatively simple. We just don't want anything repeating, so we use a set. But definitely the conditions gets harder and harder and trickier to kind of make sure that we're holding it right. But still, the idea would still be the same. Cool. That's all I have for this problem. Let me know what you think. I'll see you tomorrow and stay safe. Bye-bye.